Hey mathematicians, let's take a look at section 1.4, all about perimeter and area in a coordinate plane. So we have two objectives. We want to be able to classify polygons, and we want to be able to find perimeters and areas of polygons in the coordinate plane. All right, first, key point. A polygon is a closed plane figure formed by three or more line segments called sides. And two sides intersect at a vertex. Let's take a look at polygon A, B, C, D, E, and that's how you would name a polygon, is go some direction around, so either clockwise or counterclockwise, either way, doesn't matter, and then just go in order of vertices when you name any polygon. And then as you can see, the sides are always segments, and sides come together and meet at a vertex, so in other words, the corners. And polygons are named by the number of sides that they have. So let's take a look at our list here. So three-sided, you're probably most familiar with these first few items on the list. And you may or may not remember the ones that are bigger than 5 sides, but definitely get familiar with this list of polygons. And then past 12, so whatever number of sides there are past 12, we would say that number gone. So let's say it's 15 sides, so we would say 15 gone. If it's 20 sides, we'd say 20 gone. 100 sides, so we'd say 100 gone. All right, there's two adjectives that we can describe our polygons with. We have convex and concave. So basically, convex is anytime the sides are extended beyond the corners, and no point of intersection is on the interior of the polygon, that's considered convex. And then the type of polygon where if you extend a side, any more than one side you extend and the points occur on the interior, that's a concave. All right, let's take a look at these two shapes. Classify each polygon by the number of sides, and then tell whether it is convex or concave. So first, let's look at the number of sides. So we have 1, 2, 3, 4 sides, so that makes it a quadrilateral. And then for the concave versus convex, you're looking for whether the sides appear in the interior. So there's one side extended and another side. So right here, it's on the interior. So that means it is a concave. Let's take a look at our next shape. So here we have a polygon who has 1, 2, 3, 4, 5, 6 sides. And that's a hexagon. No sides occur on the interior when I extend them, so this is a convex. And here's a little bit cleaner version of the information we just talked about, so you can pause the video here to update information in your notes. If not, keep on going. All right, so key point number 2, perimeter and area. So let's just get a quick definition of both of these. So perimeter is the distance around a polygon. So you want to follow the edge all the way around any of your polygons and add up all the number of sides. So it's the distance all the way around a figure or polygon. And then area would be this space inside. So if I were to shade, like we have this shaded rectangle is orange, so all this shaded region would be considered the area. You can use area and perimeter formulas in the distance formula, where we learned about in notes 1.2, so distance formula was mentioned in notes 1.2, to find perimeters and areas of polygons in a coordinate plane. So anytime you're in a coordinate plane, you can always use distance formula, in other words, Pythagorean theorem, to figure out diagonal lengths. And then you've got these formulas for area, squares, and rectangles to actually figure out perimeter and area. So let's take a look at this example. Find the perimeter triangle ABC with the following vertices. So take a moment to plot these points. All right, so your triangle should look something like this. So it's appearing to, the vertices appear to be in all of quadrants 2, 3, and 4. So think of perimeter. So perimeter would be the distance around. Well, to find these vertical lengths and horizontal lengths, you could just count the number of units. So from this vertex A to this vertex C, you're moving 1, 2, 3, 4, 5, 6 units. So this has a length of 6. And then count from vertex C to B. So counting, start here, this is 0, then go 1, 2, 3, 4, 5. So we have a length of 5 along this side of the triangle. So when you do that counting, you're using the ruler postulate. So sides BC have a length of 5 and CA have a length of 6. All right, now let's look at the length of side AB. Since side AB goes at a diagonal, this is where you want to use distance formula. So that's going to be the big square root, and then you've got your x2 coordinate minus your x1 coordinate squared plus y2 coordinate minus y1 coordinate squared. So now you plug in your numbers in all the right places, substitute your coordinates, x and y coordinates, and then simplify using order of operations. So you should get 5 squared plus negative 6 squared. And negative, no matter what, whether you're squaring a positive or a negative number, doesn't matter because all numbers will result in positive product. So you should have gotten square root of 61. Your other option is to plug in your numbers to use the Pythagorean theorem. If you do that, you also would get square root of 61. Either formula is acceptable for figuring out distance and length going at a diagonal. Now make sure when you round off your values that you do round to 3 decimal places. So here we have 7.81025. So you would go to the 0, and this is the place where you want to stop. You always look at one number after. If it's less than 5, leave this third spot alone. If it's greater than 5, then you want to add a number, one value to whatever's in this third position. Since it's a 0 here, and this next number is a 2, 2 is less than 5, so I am not doing anything to the 0. It's going to stay as is. So to 3 places would be 7.810. All rounding is to 3 places unless told otherwise. All right, now let's check out an example 3. Find the area of triangle DEF with the following vertices. So pause here and plot your points and connect to form a triangle. All right, so your triangle should look something like this. So if we want to find area, think about your area formula. So you can look up area of a triangle, or if you remember it, it's basically 1/2 times your base times your height. So for the base, that's easy. You can just count across using your ruler postulate. So 1, 2, 3, 4, 5, 6, 7, 8. And then we need to sketch in our height. We can't see the height. And the height always goes perpendicular from one vertex to a side. There's your height. So since it's a vertical distance or length, that's also counting using the ruler postulate. So you go 1, 2, 3, 4, 5, 6. So my height is 6. And that's all I need to do to find area. All right, so from F to E, we have a length of 8. We sketched in our height and counted and got 6 units. So next you would plug in the 8 and the 6 for base and height into your area formula for triangle and do from left to right. So half of 8 is 4, 4 times 6 is 24. So the area of triangle FED is 24 square units. All right, next we're going to use an example real-world situation. You are building a shed in your backyard. The diagram shows the 4 vertices of the shed. Each unit in the coordinate plane represents 1 foot. Find the area of the floor of the shed. So it looks like the shape of the shed is a quadrilateral. So to get area of a quadrilateral, we need the length and the width. So it doesn't matter which sides you pick for your length and your width at this point. So count 1, 2, 3, 4, 5, 6 for length, and then 1, 2, 3, 4, 5 for your width. So you're using your ruler posture and you just count vertically and horizontally. All right, now just plug in these numbers into your formula. And 6 times 5 is 30. So the area of the floor of the shed is 30 square feet. Now I want you to try these on your own and bring in your answers and clarifying questions tomorrow in class, and we will go over these problems and more. So be ready to clarify any questions tomorrow. And I am so ready for some fall football, and I think this guy is too. See you in class.